Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and this will be the third video on stoichiometry. So if you haven't watched the other two videos, I recommend doing that. But let's get into it. This video is going to be focused on limited reagents, okay? And we're going to start off by looking at ingredients, like when we're baking a cake, okay? Now, if we were to have 2 cups of sugar, 2 large eggs, 1 cup of butter, 3 cups of flour, 2 cups of chocolate chips. These are the things that we need to make cookies. But you'll notice that we're limited on one item, and that is sugar. The sugar is our limiting ingredient because we can't make the recipe as prescribed because we're missing about a half a cup. Okay, and you can see that I've written it right there up above. Okay. Now down below, these are what we call our excess ingredients. Okay, we have plenty of ingredient left over to possibly make a second batch, okay, or even a third, depending on how much you actually need. All right, so this is like you rummaging through your cupboard and trying to find the ingredients, and you realize, oh, I'm a little short. You know, I got to go back to the store or go to the neighbor's house, you know, see if anyone has any, right? So the idea here, we're going to take the same concept and apply it to chemistry, okay? So right here is our example of a balanced chemical reaction. Now, in the lab, it's not always going to just be all perfect like this. We're not just going to have magically every one molecule matching up with 3 molecules to make 2 molecules of NH3. That's far from the case. We don't live in a perfect world where everything just lines up ideally, okay? What really exists is we have something like this. We have 2 molecules of N2. We have 3 molecules of H2. And we want to know, well, how much can we make? Well, from our example, we can make 2 molecules of ammonia, but then we're left with 1 molecule of N2. All right, so this would be our excess reagent. And then our limiting reagent is the thing that limits basically how much the reaction, or how far the reaction goes. Okay, so what you'll realize is if we're working with 2 things here, one will always be limiting, one will always be excessive. All right, so what we're doing is we're just modeling it out what it looks like on a molecular level. Let me just clear all this out real quick. All right. Now, down below, let's actually apply this concept of a limiting reagent. Okay, now a reagent is a part of a reaction, basically. All right, so like, for example, up here we have hydrogen and nitrogen. They are reacting together. They are both what we call reagents that are part of the reaction. Okay, they're on the reactant side. Okay, now in this example, okay, we have copper reacts with sulfur to form copper 1 sulfide. What is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? So the first thing you have to do is to balance the equation. So in this example, okay, we have 2 coppers for every 1 sulfur, and then we end up creating 1 copper 1 sulfide. Now, if you need a little bit of a refresh, you're like, wait, copper 1, what does this 1 mean? Well, so in this example, copper is only going to give 1 electron. Okay, now sulfur on the other side, right? Remember the givers and takers? Sulfur wants to take 2 electrons. It wants 2 electrons. So is that balanced? No. So 1 copper is only giving 1 versus sulfur taking 2. That means we need 2 coppers to make this balanced. Okay, and that's just a review of chapter 3. Okay, so what we're doing is we're balancing out this equation. Okay, we balanced out the compound. I just showed you how to do this right here. And then now the coefficient out front is what we're changing to balance the reaction. So we need 2 coppers for every 1 sulfur. Okay, so here's our mole ratio. And then we have to write out below our grams, the amounts that we have of each. Okay, now you may say, well, we have more copper because it's 80 grams, but is that necessarily the case? Well, copper is a lot heavier of an element than sulfur is, right? Like copper is 63 grams per mole, while sulfur is only 32 grams per mole. And so copper is heavier. So does that mean necessarily that copper is the excess reagent just because the value is higher? You cannot assume that, okay? And you're probably going to see down below what I'm alluding to. So the first thing you have to do is convert each of these into moles. So we have 80 grams of copper converted to moles gives us 1.26 moles. And then we have 25 grams of sulfur, and we convert that into moles. We have 0.78 moles of sulfur. Now you may say, well, okay, Mr. Flynn, I have 1.26 moles of copper. That must mean this must be my excess reagent, right? And this must be my limiting reagent, right? Because it's less than this one. Well, you have to consider our now mole ratio of 1 to 2. So we don't know that that's the case. You can't assume based on the moles. We have to now do the comparison, okay? And the comparison we make is down below. So what you're going to do is just pick one. It doesn't matter which one it is, just pick one. In this example, I chose copper. So 1.26 moles of copper, and I compare it to my mole ratio, which is 1 to 2. And then what I'm going to do is line it up. And so 1.26 divided by 2 gives me 0.6. And then what we're going to do is compare. So what we're doing is saying if I use all of the copper, if I use all my copper, which is 1.26 moles, I will need 0.63 moles of sulfur. And then I say to myself, well, how much sulfur do I have? Well, the sulfur that I have is 0.78. I have plenty of sulfur. I even have some left over, okay? So when we're doing this, you need to recognize, okay, you have to do the comparison because in this example, I have plenty of sulfur. So sulfur is my excess reagent. So I have it written here as a phrase, and this is how I want you to say it to yourself every time. If I use all of the copper, right, another arrow there, I would use 0.63 moles of sulfur. In the reaction, I have 0.78. So that must mean that copper is the limiting reagent. I want you to tell yourself this story every time you do this. And you won't go wrong. So if I use this, if I have this much copper, I'm going to use this much sulfur. And then how much does that compare to how much I actually have? And you can do it the other way. And if you do it the other way, you'll end up finding, that copper will be the limiting reagent. Either way you set this up. You can even use the sulfur as the example. I have this much sulfur. This is how much copper I'm going to use. Oh man, I'm short. I don't have enough copper. Okay, so you're basically maxing out. You're maxing out one of the variables and you're seeing which one, how it compares. Okay, now down below, we can take this problem and go a step further and we can actually figure out how much we can actually make. So in this example, we're using the same values. We have 80 and 25, okay, in relation to the copper and sulfur that we're working with, okay? And we found that the limiting reagent was copper. Copper is the limiting reagent, and we want to know how much copper 1 sulfide can we form? How many grams can we make? Hey, and this comes back to something we've already learned, already practiced. Let's put it together, right? And so you're going to take your given value, 80 grams, but we can't work with grams. We have to work with moles because we're doing a mole ratio. And the mole ratio is 2 to 1. We're doing a mole ratio. So we have we convert it into moles, and then we do our mole ratio. And we set it up so that the copper cancels, and we're left with copper 1 sulfide on top. And then we convert our copper 1 sulfide into moles, right? So 2 coppers plus a sulfur is 159.2. And then when we do the math, we end up getting 100.2 grams. So this is basically, this bottom half is review from the previous video. The top half, like this section right here where we're finding the limiting reagent, we're combining them and making a multi-step problem. Okay? Now, the purpose of finding the limiting reagent, okay, the purpose is to figure out what's preventing the reaction from continuing, right? It comes back to that same example. If I have 5 pieces of ham and each sandwich needs to have 2 pieces of ham, well, I can make 1 sandwich, 2 sandwich, and then I'm left with 1 piece of ham, right? And so that's limiting how much I can make. It won't let me make 3 sandwiches because I don't have enough ham. And let's just assume I have tons of bread, tons of cheese, and all the other ingredients. But the ham is the limiting reagent. We have to figure that out. And we have to do that through 2 steps. Okay? Basically, right here, converting it into moles, and then maxing out one of them and doing a comparison. okay? And you will get practice with this as you do it over and over again. And if you need to, come back and watch this video and say like, oh, it's coming back to me now. I remember this step. Sometimes we just need a little bit of a refresh, okay? And combining this all together is basically the goal, all right? We are combining all the days of learning into this video, okay? All right, thanks again for watching. Till next time.